Yeah. Hello, good afternoon, everyone. Welcome to second and Women's Day special edition of Institute of Concrete Technology ICT-SYPro's webinar series. Today's topic is digital concrete surveillance. As you know, industry and the world is moving towards more digitalization. It enhances efficiency, agility, and creates more value by integrating different technology together. It also fosters innovation and drives growth. Today we have two eminent speakers to talk on this topic. Helen from Verifi Technology and Cassandre from Aggregate Industries. We also have our ICT President Colin with us to give a Women's Day address to all of us. I invite Colin to address the audience. Colin.
You're muted, Colin. I don't know if you can hear me, but I have no sound at all.
Oh, but we can hear you.
You'd like me to do my introduction, yes?
Yeah.
You're going to have to nod a little bit further. I've got literally no sound at all. Okay, then. Hoping that everybody can hear me. Thank you. I'm Colin Nesfield. I'm the president of the Institute of Concrete Technology. I'd like to welcome everybody attending to today's seminar, which has been organised by the Institute of Concrete Technology's Student and Young Professionals Network, ICT-SYPro. This is the second of their webinars, and this is their first full year of operation, and I'm encouraged to know that they're currently planning to run these webinars quarterly. I'd like to personally thank those members of the network who have organised today's event, and to encourage students and apprentices of all ages, recent graduates and young professionals, to consider joining the ICT and taking part in the activities of the ICT-SYPro network. You can find out more about the ICT through our website, theict.org.uk, which is, of course, a digital source of information, as so many sources are these days. And in an age of digitization, automation, robotics, artificial intelligence, you name it, the digital world is ever present and impacting on our lives throughout industry, science and education, which leads me in a nice segue to introduce today's webinar. Can I welcome you all to the ICT-SYPro Women's Day webinar, Digital Concrete Surveillance.
Thank you, Colin. Hello, everyone. I'm Helen Frape, and I'd like to thank the ICT Student and Young Professionals Network for inviting me to speak today on International Women's Day. I'd just like to say a few words about my career so far. I've been working in the construction industry for nearly 25 years, mainly in the ready-mix concrete production sector, and I'd like to take a moment to reflect on the progress that's been made over this time. When I first started working at Lafarge, all those years ago, I was a bit of a novelty. I was actually the first woman that many of the plant staff had seen on their units. Welfare facilities were appalling, and there was actually no practical consideration given to women's needs or requirements as far as PPE or welfare were concerned. I do remember one plant manager ringing me before I went to visit the site and earnestly urging me to use the toilets at the local services, because I wouldn't actually want to use the plant toilet. I wouldn't want to touch it with a barge pole, he said. Well, I'm happy to say that things like this have improved beyond recognition. And I now regularly see other women in high-vis, and some of it even looks like it's designed for us to fit us. And I no longer have to hover over plant toilets, which is good because my knees wouldn't take it anymore. I actually think, all joking aside, that this industry has become one of the most welcoming and encouraging sectors for women and is reaping the rewards our collaborative and diverse perspectives can bring. So without further ado, I'm going to take you through my presentation. I'm not sure what's happened to my title screen, but somehow managed to get some crossings out on it. But we're going to move away from that onto the agenda. So today I'm going to talk about the pre-digital process of producing ready-mix concrete. And I just want to mention here that I've spent most of my working life in the continuous improvement area, looking at the production of ready-mix concrete. So I've spent a lot of time on plants and around the technology that's used to create concrete. So I am painfully aware of some of the things I'm going to talk about today. Then I want to look at the impact of digital surveillance on this process. Then I'm going to talk about Verifi, a little bit about HS2 and how we ended up getting acceptance on HS2, and then just cover briefly the benefits for contractors and clients. And then there'll be hopefully time at the end for some questions. So the challenges of the process without digital surveillance. Essentially, there is no objective visibility for the plant on what they've just batched. And why is this an issue? It's an issue because of the second point. There are many process variables that cannot effectively be controlled and make it possible to produce load-to-load consistency. For example, think about moisture. Moisture in the coarse aggregate. It exists, and on a very, very dry day, you probably will get absorption. Now, these factors are not measured continuously by any measuring device. They rely on the batcher or somebody in the process team to enter that information into the batching plant and to keep it updated. That's difficult in itself and often doesn't happen. If you look at the sand moisture, that typically is measured by a microwave moisture probe, but essentially that probe is only measuring what's flowing over it. There will be sand either side of that probe that is not the same moisture. And let's say conservatively that variance is around 1%. If you think about a metre of concrete, it contains around 800 kilos of sand. A 1% variation in moisture represents 8 litres. Now, 8 litres can change the slump of the concrete quite a lot. And that 8 litres might be there, it might not be there. We don't know. So if you do not have visibility of what's just been put into the back of the truck, you are not able to see really what you've just batched accurately. So you've batched the load. Is it homogeneous? Well, we can't actually tell. If it's a wet batch plant, it probably is, as long as the mixing times have been adhered to. If it's a dry batch plant, it probably isn't. And even if it's wet batched, you can't tell if the admixture is thoroughly mixed or if it needs to have time to wash off the sand. What I've discovered in my career is that batching sequences are not always correct, but without visibility of how the load changes over time, you won't know whether they need to be corrected. Some batches are very good. Some batches will change things for a good reason. They might forget to change things back again. There is a lot of unknown. There is a lot of stuff, a lot of variation that cannot be seen or detected. So you've got the load in the truck, it leaves. It arrives on site. People's perception of slump is drier than in reality. When the truck arrives on site, the test phase is actually just generally somebody looking at the load of concrete. Sometimes they don't even bother to look at it because on site they assume that the load will turn up drier than they want it. I expect it to be dry because actually when cement touches water, there's a hydration reaction and that produces heat. And often the concrete will dry up naturally. And in summer, on very hot days, that is exacerbated. And so sites are used to concrete arriving at a lower slump or looking at a lower slump than they think it should be. That then leads to water addition on site. And often that's uncontrolled and often it's undocumented. Sometimes it's written on tickets, but there is no guarantee that what's written on the ticket, whether it's a manual ticket or an electronic ticket, there's no guarantee that what's been written is what actually went into the truck. The resulting measured, I say measured, it's not really measured, is highly variable. And producers know this, and they try and mitigate these issues with higher cement content. But as we all know, cement is very expensive. It's also got a high carbon footprint, and we all need to be looking at ways to reduce it. So essentially, what does this variation look like? We can all imagine, and some of us have actually experienced this variability, but without objective data to highlight it, it's difficult to manage it and improve it. Now, Verifi has a setting called ghost mode. And when we install Verifi on trucks at a client, we typically run the system in ghost mode for several weeks. And essentially nobody knows that the system's working, but it's there in the background, quietly recording what's going on. And because nobody knows it's working, they continue to behave and do everything as they have done in the past. And what we did was we decided to collate the ghost mode data from a year from lots and lots of companies across the world, and we put it into a picture. I'm going to show you the picture now. And essentially what it shows you is the initial slump that Verifi detected for all these loads of concrete, and how it varied compared to the target, how it varies compared to the target. On the left-hand side, you can see the number of loads, and at the bottom, you can see the slump variance. So you can see that there's an enormous amount of concrete that's batched very close to target, or within plus or minus 30 mil of target. There's a lot of concrete there, but there's also an awful lot that's batched above the target, so it's wet. So this is the concrete, the first slump that the concrete gets, and this is how it's going to arrive on site before any other water addition happens. So 35% of it is above where it should be. And there's also a significant amount below where it should be. And again, this will probably end up having water added to it. And cement is overused because of this, because there is so much variability in the process of making concrete. Now, Verifi's mission is essentially to replace cement with process and data. Now, for 80 years, this variability has been invisible. Now, with these digital surveillance tools, it is visible, and we can actually do something about it. This is just a little overview, looking at the challenges that I've just talked about, and just comparing the process without Verifi and then with Verifi. I'm just going to cover a couple of them because we haven't got a huge amount of time. But essentially, one of the things that currently causes a bit of stress and trouble for producers is that they have no visibility of bottlenecks and their causes. And this can hamper productivity. And bottlenecks can come in many shapes or forms. They can be at the plant, they can be on the journey, they can be actually at the job site, caused by people's behaviour on site, often caused by sites' insistence on adding water and then not allowing the truck to mix it in properly, and then discharging a bit of concrete and then deciding it's too dry and adding some more water. And all of this is really, obviously really bad for the concrete, but it's also really bad for truck utilisation. If you actually got a system like Verifi on your truck, not only can you manage the load on the way to make sure it arrives exactly as it should do, you can also see exactly what's happening. And the fleet tracking functionality allows shipping teams to spot bottlenecks before they become a major issue, and for everybody in the process to make informed decisions. Concrete properties are visible and available to a number of users, so the driver never has to play QC technician, which is actually an unfair responsibility that's often conferred on them in a situation where there is no digital surveillance. I just want to mention about admixture addition as well. So being able to manage loads with admixture on the journey is a significant benefit, because you actually get better utilisation out of the admixture when you delay addition and add it during the journey. And from our experience working with several clients across the world, we've discovered that you can reduce your admixture usage by up to 30% by delivering it in transit. So that's a massive benefit. Finally, at the job site, having all this variation leads to job site delays, it leads to concrete being rejected, it leads to arguments and issues between the producer and the sites. And it's actually very costly. It takes an enormous amount of management time to investigate these issues and to try and find out who's going to take responsibility for them. When you've got a system like Verifi, all of this is visible. There is no argument. It's there, it's available, it's instant. And you can see exactly what's happened to the load from batching to discharge. There are no questions. So essentially, Verifi allows the production process to be compressed to only the essential steps. And it brings visibility benefits, productivity benefits, and sustainability benefits. And we independently asked the Carbon Trust to independently analyse the sustainability benefit for us, because obviously, you know, we can make claims, but they need to be validated. And looking at the data that we produced from various of our customers, they have decided, I'm sorry, I can't actually see what the number is, but that number has been validated by the Carbon Trust. So the little zoom pictures are sitting over it. So it is a significant saving from a carbon point of view. The productivity improvements also are massively helpful for the whole supply chain, because if you can utilise your resources better, you can pour more concrete, you'll finish jobs more quickly, and you'll then not be taking up road spaces, or you'll be able to open networks quicker than you would have done in the past. And then the visibility, the digital record, it's comprehensive, every single load, all of the events in that load time-stamped from batching to discharge. And it essentially means that the producer can demonstrate compliance for every single load of concrete. So I hear you say, what is this magical system? So essentially, Verifi is a series of cloud-connected sensors fitted to the ready-mix truck that enables the measurement and management of fresh concrete properties. And we also measure and record certain truck-based functions. So we're looking at things like the drum revolutions, how fast the drum's going and how many revolutions it's doing. We have a little display on the back of the truck that shows the slump or flow of the concrete at various points in the process. We measure the fresh concrete temperature. We measure the geolocation of the truck, and we know whether the truck's in charge or discharge. Now, data from these sensors is used along with information from the batching system and some of our patented algorithms to derive a slump or flow of the concrete. And that information is displayed at various points, both on the truck. We have an in-cab display so the driver can see the information, have an external display, and we also have the Verifi hub, which is where the users at the producer and potentially other parts of the process can see all of this information. So the sensors output something on the left-hand side which looks horrible, and only the very clever people in our R&D team understand what that means. But fortunately for us mere mortals, the stuff is all beautifully presented via maps and charts and allows us to see exactly what's going on with the load and see where the truck is at any point in time. Very importantly, we have a link with the customer's batching system. The batching system not only sends us information about the type of concrete being batched, but it sends us very accurate information about the amount of water that's been added to the concrete, both through the moistures that we've talked about and through the free water added and any temper water added. That then allows us to decide whether we've got any water to manage the load with, because most importantly, we will only manage the load with water up to the design water cement ratio. We cannot break that, because that obviously then has an impact on durability and strength. So we take that information from the batching system and we use it to program our system, program the Verifi system with what's available to manage the load. And once that water is used, then a flag is placed on the load to say that there is no more available water. And if there is no available water after batching, again, that flag will go on the load. Some customers allow us to manage with admixture, and that can be set up on certain mixes, because not all mixes will be able to be managed with admixture. But again, it's all completely down to what the producer has decided is appropriate. Now, what's Verifi's main differentiation? Well, apart from being able to manage the loads of concrete with water or admixture, the system has actually been designed by people with deep knowledge and experience of the ready-mix industry, particularly the ready-mix production industry. We are also very lucky to have concrete science and cement chemistry individuals supporting our team. And we have data scientists and software engineers also in the team. So they're able to take that information and make some sense out of it from a predictive analytic and maths point of view. So a system designed by concrete people for concrete people, but taking the best of other innovators and other people from our teams at GCP and Saint-Gobain Construction Chemicals. So I'm just going to talk a little bit about HS2. For those of you that are not aware of the size and scale of the project, there's a little picture on the left-hand side which shows the geography from the kind of central London region all the way up to Birmingham and a little bit beyond. But the bit that we're concerned with is the N1 and N2 section, which I think is in blue at the top of the screen. Now, essentially, this utilises 2 million cubic metres of concrete. There's going to be 42 viaducts, 66 overbridges, 56 culverts, lots of embankments. It's enormous. And actually, that 2 million cubic metres of concrete doesn't include all the enabling work. So there's actually quite a bit more than 2 million cubic metres of concrete. And the HS2 specification requires every single load to be tested for slump. Now, that's very expensive. It's quite carbon heavy because you've got technicians running around in vans. It's very labour intensive as well. It's an enormous project, really. So we decided that it would be great to get the technology on HS2. And we knew it was going to be a challenge because we obviously have a very high stakes project, and we have what in the client's mind is potentially an unproven technology. And actually, you've also got the history of 80 odd years of doing things a certain way. The slump test, I think, is even older. It's been around 100 years. Raman can probably comment on that. Not because you were there, Raman. But essentially, we thought, well, you know, it's now or never. We've got to try this. Now, BBV at the time were thinking about this fact that every load needed to be tested because it is enormously onerous and would require an enormous amount of resources. Probably don't even have the, you know, that number of technicians in the country, to be honest. And they started thinking about alternatives to the manual test. Around the same time, Tarmac were tendering for the concrete, and at the time, Tarmac had Verifi on all their trucks in the UK, and they actually included Verifi in their tender for the concrete supply as a means of differentiating themselves. And BBV were interested, but they were cautious because they'd never seen it in action on a large project. Fortunately, around that time, Extruder Curb had Verifi installed on their trucks, and they were doing major highways projects along the M6 managed by Balfour Beatty. And so the Verifi team, along with the Extruder Curb team, were actually able to demonstrate the system capability on this project to Balfour Beatty's satisfaction. And believe me, it was a bit of a journey because initially there was a lot of scepticism and distrust of the system. But over about 3 months, we managed to change that and turn that around so that BBV actually became, converts really to the technology. And in late 2019, they actually specified that Verifi should be used to deliver all the concrete to the N1 and N2 sections that they were responsible for. So in September 2020, we started a full-scale trial with Tarmac and BBV to demonstrate that digital testing is actually a safe alternative. And what we mean by safe is that the digital test is not going to approve any concrete that the manual test would have rejected. That's really important, because what we don't want to be doing is putting concrete that's not suitable into the structures. And so essentially the trial period was us measuring the concrete and the technicians measuring the concrete. And not just the Balfour's technicians, but some Tarmac technicians were involved as well. So we were trying to make sure that we had a good spread of manual data and we had plenty of verified data. And in May 2021, Balfour's submitted the results of the trial to HS2 for approval. And the rest, as you know, is history. HS2 agreed to a departure from the specification and allowed BBV to progressively replace manual testing for consistence, temperature and cubes with Verifi via a staged approach. Now, the staged approach is essentially quite onerous, but it's onerous for a good reason. And it's to give HS2 confidence that what they're approving and what they're supporting isn't actually going to endanger any of the works. So step one, it was to create some families of mixes, which Balfour's did. So similar mixes are grouped together a little bit like you do with QSUM families for conformity. And we agreed with HS2 that for the first 1,000 of each of those families, the first 1,000 loads of each of those families, we would produce Verifi data and manual data. And then once everybody was happy with those results, we would move to stage 2, which allowed us to test 1 in 24 cubic meters. So essentially, every third load is tested by a manual technician, and every single load has Verifi data. And that information is compared. And if everybody's happy, we move to stage 3, where we test 1 in 50 cube, and so on, to the end where we're testing the minimum, which is 1 in 200 cubic meters. Now, there's 2 things that Verifi is assessed on. A, is it kinder or harsher than the human being? Is it allowing concrete into the works that the human being wouldn't? And actually, it turned out that Verifi is slightly harsher than the human being. And that actually isn't a surprise, because Verifi is a machine. It's not affected by Friday afternoon, pouring rain, everybody knowing that this is the last load of concrete that can be delivered. It just tells you the result, no matter what the context or the environment is. Whereas technicians, being human beings, will be influenced by factors that a machine won't be. And the other thing that was Verifi had to show was that that its measurements were within an acceptable distance of the manual test. Now, I always say, actually, it's the manual test that has to be within an acceptable distance to Verifi, because Verifi doesn't change. Verifi will measure the same today as it does tomorrow. But the manual test changes people, because it involves people and it involves lots of different movements and actions. And essentially what we've managed to do over the time period since we started this work with Balfours and the producers, Tarmac and AI, is to prove that the vast majority of concrete that we've measured is within BSEN 12350's reproducibility limits. And you can see this lovely little chart here. This shows the change over time. And you can see there are a few little dips where we dropped outside those limits, and those are definable and assignable to when some new mixes were introduced, and they were very unusual mixes and we weren't measuring them very well. So what we did was we changed our maths and we measured them. We improved our ability to measure them. And you can see that you can see that our measurement comes back in line. There are limited new mixes now on HS2. All the mixes were defined and set up at the beginning of the project and gradually became used over the first few months of the project. And so now, because we know all the mixes and we know how to measure them all, we don't have these big dips anymore that we used to have, or that we had on 2 or 3 occasions. The reason that we share this information is because it's important for everybody, for Tarmac, AI, Balfours, and the client to see and understand the process, the digital process. So if it's a new concrete and it's got some new admixture combinations in it, or it's got a new percentage of slag in it, very high slag mixes, or something with fibres, something a bit weird and unusual, we can attempt to measure it, and we'll measure it reasonably accurately, but not accurately enough for this process. And we learn, the technology learns over time. So finally, I just want to talk a little bit about, we talked a lot about the benefits for producers, but we haven't talked much about the benefits to the contractor and the client, and arguably they are greater. So the first one I want to talk about is safety. If you've got a digital surveillance tool in progress, you are going to improve safety because you are reducing the vehicle people interface. You've not got technicians around the truck as much. You've not really got the driver getting in and out of the truck as much as they might have done before to make all of the water additions, because the water addition can be done automatically in the cab, if indeed it needs to be done. Secondly, you've got productivity benefits. If you've got better utilisation of your resources and trucks are not spending as much time waiting around on sites, you will do your pours in less time, and your projects overall will take less time. Waste reduction. The waste reduces cost and the management time to investigate the causes of the waste, time to deal with non-conformities. And that's a huge benefit, not just because you're saving money not having to buy as much concrete, but because you're saving money not having to have your resources caught up in things that are often not really adding any value. The CO2, reduction in CO2 is a benefit for all. everybody needs to prove that their sustainability credentials are valid and that they can reduce CO2 on their projects. Verifi enables this in several ways. Digital records are really important. They allow the contractor to seamlessly collate data about the project structures, any manual test data that they have, and Verifi data into detailed POR records. And this can be done on the day of production. And this allows the client to see compliance records for every single load and every structure quickly and easily. In the past, this data was manual. It may have been captured, some of it on a tablet, but lots of it was on paper. And there was a whole exercise to try and bring it together and produce it, put it into a format that the client could use. And you didn't have any of the data that Verifi now supplies about the load from batching to discharge. So it was incomplete. Finally, collaboration. Because everything is now visible, it is in the interest of all parties, the contractor and the producer, to work together and to work quickly to solve problems and generate improvements, and then ultimately share the benefits. And as BBV said, they think that the work they've done on HS2 is a world-first innovation in concrete control and monitoring. So that is the end of my presentation, and hopefully time for questions. Anita? I'll let you decide that.
Hi, may I ask a question?
Could you speak up a bit? I'm struggling to hear you.
Yeah. Can you hear me now?
Sorry, I was muted.
It's okay. Yes, I'll try and turn my volume up.
Yeah, there is a question in chat from Luke Glidewell. What process or equipment would need to be installed on the trucks to deliver the admixture in transit? Also, how is the dosage of the admixture monitored? Do the truck need to have a specific COSH RASDS with them at all times in transit in case of an incident occurring?
So first part, so the truck would need to have a little admixture tank installed. In order to distribute the water, we already have something called a fluid delivery module, and that contains the flow meters and valves and everything required for fluid delivery, and it contains the admixture components as well. So the admixture is stored in a little tank which can be refilled at the plant. That as and when the system decides admixture needs to be added, it is metered in specific amounts which are time stamped, and that would be based on an agreement with what was allowable with the producer. So it's extremely flexible. You can set up designs per mix. You can even set up per plant. So you might say, at these plants, I want this admixture adding at this point in the process, and at this plant, I don't want any admixture adding to this mix type at all. So it's very functional.
Yeah, and there is a safety aspect.
Yes,
yeah.
So I would probably advise that there should be a COSH sheet for the admixture being used, kept in the truck at all times. It would make sense to do that.
Yeah. Does anybody else have any questions? You can unmute and ask it here.
Hi, can I ask a question?
Yeah, sure.
So do you see your system working well together with sensors embedded in concrete elements? Is there any need for these type of sensors to have a closed loop system thinking the full maturity of the product as well?
So BBV have actually done that work, and I would probably direct you to talk to them about it. So they have got sensors embedded in the concrete on the same section of the project, and they pull data from those sensors and they collate it with Verifi data and their lab data to produce this POR record. So yes, it is happening. I don't have the specifics of that, unfortunately.
No, thank you very much. Very good presentation.
There's another question in the chat. Is there a manual override?
I'm just reading it, yeah.
Is there a manual override for water adding above water to cement ratio requirements? I'm thinking to stop concrete going off the drum. It's a question from Ian Evans.
So what the system does is when when it's managing a load, if it reaches the water cement ratio, it will put a flag and say there is no more water available. Once the truck arrives on site, the driver has to press a button to say that the truck's on site. And this is a handover point between the producer and the contractor, really. There is, the system does allow the driver to add water, or anybody to add water manually through the system, but it captures it and timestamps it. So it captures the amount and the time that it was added. And the reason for that is so that there is evidence for the producer to go and manage that situation.
Yeah.
Does that answer your question, Ian?
Yes.
Good.
Yeah. If nobody has any questions anymore, I will hand over to Cassandra for her presentation. You can share your screen. There is one more question.
Okay.
Can you answer it in the chat?
Yes, I will try that, yes.
Yeah, thank you.
Hi, do you see my screen?
Yes,
Okay.
yes, we can hear you. Yeah, we can hear you and see the screen.
Okay, perfect. Well, thank you to you, Anita, and to the ICT for having me, and thank you, Helen, for the presentation. It was really interesting, and definitely a hot topic at the moment. So I will present on carbon data and environmental project declaration for ready-mix on our journey as aggregate industry. So first, I wanted to come back a bit as to reflect a bit as my position as woman in the construction industry. So I started. My grandpa was a builder. He's here on the picture, and he took me to construction sites when I was young, which is not the best for health and safety. But that was my first taste of the construction industry, and there were not a lot of men, a lot of women at this point. But I was still interested, and I kept going, and I did STEM. And after I joined Aggregate Industry and Allsim, and there are still not a lot of women, and we are still missing some role model. But I'm sure it will come with time, and I hope it will improve with time. So first of all, I will present quickly Allsim and Aggregate Industry, then our net zero strategy, and I will present your carbon report tool, which is our internal carbon dioxide reporting tool, and then I will move towards the environmental project declaration, which is called EPD. So Allsim is one of the biggest cement manufacturer company with over 60,000 employees in 70 countries. And Aggregate Industry is part of Allsim. So it's a UK division of Allsim, and we are divided in several divisions. We have a ready-mix division, which I belong to. We have a precast division, aggregate division, asphalt division, and we also have one cement plant in Cordon, which is part of the cement division. And cement is one of the main products that emit CO2. And that's why it's really important to look into it, because in the UK, almost 40% of the UK greenhouse gas emission are due to the built environment, and a big portion of it is due to the construction product and materials. So we really need to be able to track this emission, to be able to identify the hotspots and reduce them as much as possible. We have a net zero strategy, which is science-based targets, according to the science-based target. And it's divided in 5 pillars. The first one is the climate, where we want to decarbonize. The second one is people and community. Then we have the nature and environment to avoid biodiversity loss. There's a sustainable solution. And finally, circular economy to avoid the scarcity of resources. So in terms of greenhouse gases, the greenhouse gases is measured in carbon dioxide equivalent, so CO2e. In the presentation, I will talk about CO2, but really it's actually all greenhouse gases. So there are 2 types of CO2 emissions. There's a operational CO2 emission, which is associated to an operation or to a company. So you have in the operational carbon, you have the direct emission, so scope 1, and the emission linked to the electricity, scope 2, and scope 3, which is the indirect emission. And then you have the embodied carbon, which is a carbon associated to a product. In terms of life cycle stage, for embodied carbon, you have you measure the carbon at different stage. So you have the cradle to gate, which is A1, A2, A3, so the raw materials manufacturing, the transport to factory, and the manufacturing of the products. Then there are A4, the transport to site, so A1, A2, A3, and A4 as a producer is usually what we can measure. But there are other stages. There are also the use stage, the B stage, the end of life stage. So when it's A1 to C4, we talk about cradle to grave. And the last stage is the recycling stage, the D stage, which is cradle to cradle when it's A1 to D. And so in aggregate industry, we have the EPD, and we have developed first your carbon report, which is a third-party verified automated carbon reporting tool. We developed it, so it's verified by Circular Ecology. And so it has been driven by the customer demand, really. So that's why we started developing it, because we had demand from customer to be able to deliver the carbon data of our products. And before this, so we had customer asking for the carbon data. It was usually the more mature customer in terms of sustainability. And we were doing it manually, so it was really labor intensive, and there was a risk of human error when you are doing it manually. And it was not properly standardized on our side. That's why we decided to move towards a more automated version of it. So how it works is that it's integrating with our finance platform. So in it, we have the raw materials. Every raw materials has a CO2 value. And when we put a new raw materials in it, it's flagged until we can put a carbon value. The transport of raw materials of the plant is added as well. So we know where the materials come from and how they come from, so we can add the CO2 value, just the transport, and then the CO2 value will be calculated automatically. So energy use as well is being taken directly from our system, and we know whether it's electricity or gas. We also have the delivery of the product to the customer, so the A4 stage, that we know and it's in our system. And all of this together, combined with the system, give us a CO2 value for every product that we have. So for example, in my division, every mix in the ready mix division has a CO2 value. And it looked like this. So when a customer asks us their report, the carbon report, we deliver a report like this with a different the project and the item group, so what type of mix it is, and we have the quantity and the CO2, so A1 to A3 first, so kilogram of CO2 CO2 equivalent gates, so it's cradle to gate divided by the quantity, and so it's in cubic meters for ready mix concrete. And then we have the A4, which is when it's A1 to A4, so with the transport. So in terms of process flow, how it works is that a customer will make the demands to their commercial contacts. The commercial contact will send it to one of our analysts, which will issue, which will do the calculations. They will do the calculation, and then the report will be sent to the commercial team, which can come back to the customer, give it to them. And we can also, it will help identify some hotspots and how we can improve it in terms of sustainability, how we can improve the mix, how we can improve the process, and what are the different options. And most requests are turned around in 2 to 3 working days, usually, when we are not overflowed. In terms of benefits, the main benefit is that it helps with the scope 3 for the company, for our customers, so they can ask for value and then they can report it as the scope 3 carbon dioxide emission. The calculation follows the main standard EN 15804 and is third-party verified, so people can trust our data. The value also have been supplied to Causeway for the scope 3 projects, which Aggregate Industries have been usually involved. And he helped us as well. He provided us knowledge and data to start our journey to have EPD, because we understood how life cycle work, which data was needed, and etc. So it was really a first step towards the EPD. And right now, in terms of development, we have life carbon value for all materials, and the technical team can now advise the client depending on the CO2 value and also the parameters that were there before. And we added recently, I think a month ago, we added the CO2 value to the quote, so customer can make the decision based on the mix, the price, and the CO2 as well, and other data. So in terms of EPD, which stands for Environmental Product Declaration, it's EPD is an independently verified document that provides the environmental performances of a product. A EPD is a type 3 environmental declaration according to ISO 15025, which is the best type of environmental label and declarations that you can have. And you usually have the scope of the EPD here, where you see in 2, which in this case is for a C3240 done in one of our plants. So when you have an EPD, what you need to look for is the issue date, so the 2 here, because an EPD is only valid for 5 years. So if it's out of validity, you shouldn't take into account the data. And an EPD should be third-party verified. In Europe, it's according to EN 15804 plus A2 if it has been done after 2019. And you can usually see it in the 1 here. So you can look for it, and it's supposed to be signed. And in the EPD, you have obviously the global warming potential, which is a CO2, which is one of the main criteria right now, but you have also impact category. So you will have, for example, the ozone depletion, which used to be really important, the use of fresh water, but also other circular impact category, like the use of secondary materials and etc. And it can help the customer decide what they want and what they care the most in their projects. So it's really practical and it's transparent. So there are several types of EPD on the market. You have industry association EPD, like for example, in the UK, you have the UK average SEM1 EPD done by the MPA. So it will be every company that is part of the MPA will give the data for every plant for the SEM1, and the MPA can do an average and then have the EPD verified. So if you want to know more or less how much is the CO2 for the SEM1, you can look at this EPD. So it's practical to give you an idea of where you stand. You can have an individual company EPD, so it will be product specific, but average in plant for one company. So, for example, in this case, is an EPD for every grey cement in Romania for all SIM. And they will do an average of every grey cement, but just for one company. And then you have individual company that are plant and product specific EPD, which is the direction that we decided to take in the UK as Aggregate Industry. So it's really for one product in one plant. So it's the most precise type of EPD you can have. The process to have them is divided in 5 steps. The first one is the data collection that is done by the manufacturer. So in our case, it really helps that we already did it for your carbon report. Then you have the life cycle assessment that is done by a consultant. And then they run a background report. So this stage takes 1 to 3 months. And then the background report is handed to the third-party verifier. This stage used to take 1 to 2 months, but the verifier that we are using currently as Aggregate Industry is overflowed with demand. So it takes 12 months right now, so 12 months waiting time. And then we have the publication, which takes only 1 to 2 weeks. So in London, we have 12 plants that have several EPD for their products. And this project took 2 years to do, but we're really happy from the result, and we learned a lot on the journey. And now we are working to have EPD for Manchester, Lancaster, Liverpool, and Birmingham as well. And our consultant that we're working with to do our EPD is Climaters. It's a startup based in the US, and they have developed in the US a EPD generator, which we currently don't have in the UK, but we very much want to have it at one point. So the batching system will talk to the EPD generator to be able to publish an EPD automatically, but the EPD generator will be verified, will be third-party verified, the data will be verified, everything will be verified. Then you can still be an EPD, so it's a more automated way of doing it. And in US, they are really happy. It has been a massive shift for them because it allows them to go beyond pre-established specification and achieve more sustainable design. So it's easier to make choice. So that's where we are in our journey right now. If you have any question, feel free to ask them.
Thanks, Cassandra. It was really informative. I have a question actually. These digital EPDs, does it account for the variability in cement content within the same mix? The variability in cement content within the same mix? Does it take into account, is there a plan to take into account the actually batched cement content?
Yeah. So the EPD generator is attached to the batching system.
Okay. Yeah.
So it's as precise as it can be.
Yeah. Yeah, that's interesting. Does anybody else have any questions? There are no questions in chat currently. So yeah, thanks Cassandra and also Helen for presenting for Women's Day for ICT-SYPro. And I would encourage all the audience to encourage students and young professionals in your network to join our SYPro network. I will share my screen on how to join. You can fill the application form in ICT website. Can you see my screen?
Yes.
Is it how to join slides? Okay, yeah, this is how you can join for join ICT-SYPro network. You can go to ICT website and select and connect. And if you are a student, you can fill up a student application form or a normal application form. If you're a professional, you get a free student membership and learn from different experts in the field and build networks and connections nationally and internationally. And also you get different CPD opportunities through workshops, seminars, and training events. Even for today's presentation, you will get CPD credits, certificates if you applied for it. You can just email to SYPro email ID, or you can message in any of our social media websites. Thank you. Thanks, everyone. Have a nice rest of the day.
Thank you, everybody.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.